In this video, I introduce deep Boltzmann machines. Consider a two-layer restricted Boltzmann machine in which connections are only between the different layers, but no connections between units in the same layer. The energy of state V H1, H2 is defined as a sum of two edge energies between V and H1 and between H1 and H2. The probability distribution B of a visible vector V is defined as a Boltzmann distribution, where Z is a partition function. The conditional probabilities over hidden units and visible units are computed by logistic functions. Because the H1 is connected to H2 and V, so we have two terms as input to the sigmoid function sigma. Instead of training the entire model, we use a gradient unsupervised learning to train each restricted Boltzmann machine at a time. After the model is trained, the model is a deep belief network in which the top block is the undirected graph and the rest of the blocks is a directed graph. We only need to train the backward path because the forward path is not a part of the model. We use the forward path to provide the initial value of each deep restricted Boltzmann machine using the trained W from the training data. After learning the first restricted Boltzmann machine in the stack, the generative model is equal to the margin of joint probability of V and H1 over H1. In the second restricted Boltzmann machine, the distribution H1 is equal to margin of joint probability H1 H2 over H2. Because the second restricted Boltzmann machine is not directly back to the training data, so we need to learn the W to provide the initial value for the second restricted Boltzmann machine from training data. For example, we can use the average of probability of H1 condition on the training data set as the initial value for the second restricted Boltzmann machine. Right now, we have two H1 layers, but only have one H2 layer and one visible layer. To combine two blocks in one single system, we need to modify the restricted Boltzmann machine. For the lower level restricted Boltzmann machine, we double the visible layers, and we get this conditional distributions over H1 and V. For the top level restricted Boltzmann machine, we double the H2 layer and get the conditional distributions over H1 and H2. After the two models are composed to form a single system because we have two H2 layers, we have two H1 layers, and we have two visible layers. So we get a single system here. And the conditional distributions over H1, V, and H2, which are same as the conditional distributions of a restricted Boltzmann machine. Therefore, deep belief network becomes a deep Boltzmann machine through the greedy pre-training of a restricted Boltzmann machine. For more details, please check with these references. Thank you. Bye.